Today we're looking at two UK space startups, both based in Harwell, teaming up to tackle one of the biggest challenges in space-based solar power. These satellites will be enormous, potentially kilometres across and weighing thousands of tons. Far too large to launch in one piece. Instead, the components will need to be launched flat-packed on heavy lift and future super heavy lift launchers, such as Starship. Once in orbit, robotic systems will assemble the solar panels and other modules into the final structure. Robotic assembly will be essential for building and maintaining giant structures in space. A commercial-scale space solar power system will likely consist of millions of solar panels, supported by structural trusses stretching kilometers in length, generating hundreds of megawatts of clean energy that can be beamed down to Earth as microwaves. Space Solar is developing space-based solar power satellites, while Magdrive specializes in high-efficiency plasma propulsion systems. By combining their expertise, the two companies aim to develop the technologies needed for large-scale in-orbit assembly. Let's take a look at their strategic alliance and what it could mean for building clean, scalable, and practically unlimited power from space. Space Propulsion and Infrastructure Innovation Initiative. This initiative was announced at the Farnborough International Air Show in March 2025. The strategic alliance between Space Solar and Magdrive is formalized under the Space Propulsion and Infrastructure Innovation Initiative, or SPI³. It reflects a concerted push to realize space-driven clean energy and help the UK achieve its long-term goal of producing scalable, sustainable energy directly from space. SPI³ specifically addresses the major challenges of transporting, assembling, and maintaining large space-based solar power infrastructure in orbit. As part of the initiative, both companies are working together to refine propulsion requirements tailored to solar power satellites, while also exploring wider applications for these technologies. The partnership is targeting a demonstration of a 30 megawatt system. A key focus is the propulsion needed for orbit raising, station keeping, and shape control of these giant orbital structures. Recent progress from Space Solar and Magdrive. In June 2025, Space Solar successfully completed the Albatross project in partnership with the UK Atomic Energy Authority's Robotics Division. This demonstration is directly relevant to the orbital assembly of solar power satellites, which will rely on large structural trusses to support solar panels and other equipment. Space Solar also completed the Cassidy project in April 2025. This major study, partly funded by the UK Space Agency, delivered an integrated space-based solar power design, along with a clear roadmap for construction. The company's satellite architecture, known as Cassiopeia, uses structural trusses to support the solar panels and other systems. Magdrive achieved its own milestone in June 2025, with a successful launch of two Rogue thrusters on board a deorbit mission. The company completed a comprehensive series of commissioning and firing tests in orbit, demonstrating successful plasma generation and full end-to-end system function. Both companies are making solid progress through these technical milestones, advancing the key technologies needed to deploy, assemble, and operate large-scale solar power satellites in space. The problem with Hall effect thrusters. Keeping massive structures, likely thousands of tons in mass, in orbit for decades is extremely challenging. It demands a radical rethink of how spacecraft maneuver and maintain their position in space. According to Space Solar, relying on conventional Hall effect thrusters to service these stations would require more xenon and krypton than the global supply can offer. This is where Magdrive's propulsion system comes in. Their highly efficient plasma thrusters are powered by metal, rather than expensive inert gases like xenon and krypton. Magdrive's next-generation Super Magdrive thruster is built around low-cost, high-density metal propellants that are both scalable and sustainable. Unlike traditional systems, it removes the need for cryogenics, complex pressurization systems, and toxic propellants that are common in many reaction control thrusters. Magdrive's system works by using pulses of electricity to rapidly heat and vaporize a small amount of solid metal into superhot plasma. This plasma is then accelerated by electromagnetic fields to produce thrust. Because any metal or even any conducting material can be used, it opens the door to abundant and low-cost propellant options in space. Magdrive considers their propulsion technology to be uniquely suited to support the continuous, stable operation of Space Solar's power stations. In 2025, 2 rogue thrusters for Magdrive were demonstrated in space. While this is a smaller system than would be needed for station keeping and assembly of a large solar power satellite, it successfully proved that the core architecture works. Telemetry from the mission confirmed that capacity charging, high voltage pulsing, and high energy plasma generation performed as expected. Some areas for improvement were identified, including propellant handling, injector mechanics, and in-space software updates. However, the fundamental technology functioned correctly. As a result, Magdrive now has genuine flight heritage. Following the successful demonstration, the company has secured commercial partners, with missions planned for later in 2026 and 2027. Refueling in space, a key feature needed for large-scale orbital assembly and maintenance. Magdrive's system is designed to be refuelable in orbit. This capability is essential for any propulsion system that needs to support the long-term maintenance of large infrastructure in space. In 2024, Magdrive signed a Memorandum of Understanding with OrbitFab, a US company that specializes in in-orbit refueling. The partnership received £1 million grant from the UK Space Agency. The partnership is focused on developing a replaceable solid fuel cartridge system for Magdrive's Super Magdrive thruster, which is intended to support the orbital assembly and operation of Space Solar's solar power platforms. Mark Stokes, CEO of Magdrive, has stated that their long-term vision is to source metal propellant from harvested space junk and eventually from metals mined in space, such as from asteroids. This approach makes sense when you consider there is currently over 10,000 tons of space junk in orbit around Earth. A significant portion of that mass is aluminium, which has a relatively low melting point of around 660 degrees Celsius. SpaceForge, another UK space startup, has already demonstrated a space furnace capable of reaching temperatures of around 1,000 degrees Celsius. This technology could potentially be adapted in the future to process aluminium from space debris into usable propellant rods. A team-up with SpaceForge could benefit Magdrive in helping to build a technology roadmap needed for a circular metal ecosystem for plasma drives in space. As an aside, I've already reported on Neumann Drive, an Australian space startup working on a pulsed arc thruster, similar in concept to Magdrive. They have formed a partnership with Cislunar Industries, a company working on developing an in-space furnace to reforge metal space junk into propellant rods. We now have 2 separate alliances working on metal propulsion drives that can be refueled in orbit using space debris. An Australian-US group backed by the US Space Force and a UK effort supported by the UK Space Agency. For more details on Neumann Drive's circular propulsion ecosystem, check out my earlier video on their system. Final thoughts. Recent disruptions to fossil fuel supplies caused by geopolitical events have highlighted just how important energy sovereignty is for countries. Space-based solar power offers a source of continuous 24/7 baseload power. By sourcing clean energy from space, nations can strengthen their energy independence. Ground stations can be connected directly to national grids, providing a reliable and secure supply. Even if the technology is more expensive than existing energy sources in the short term, it offers a way to cushion against future resource interruptions. This initiative from Space Solar and Magdrive could lead to a 30 megawatt platform around 2030. This represents a concrete step towards commercial solar power from space. Do you think this initiative between Space Solar and Magdrive can lead to a real space-based solar power system in orbit by 2030? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space news video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.